Let's dive straight into a material that's making waves in the coatings industry: waterborne aluminium paste. This isn't just another pigment, it's a game changer driven by environmental imperatives and performance demands. So, what exactly is this magic paste? At its core, it's aluminum flakes, but not just any aluminum. These are specially processed, often with surface treatments, to ensure they're flat, uniform, and perfectly sized for optimal performance in water-based systems. The key ingredient enabling this is water, acting as the dispersion medium. Now, the real diversity comes from two main types: floating and non-floating. Think of the floating type as the showboat, designed to sit on top of the paint film, delivering that brilliant, almost electroplated shine and top-notch corrosion resistance. But, like many showboats, it has its quirks. Poor adhesion and stability can be issues. The non-floating type, on the other hand, is more of a workhorse, sinking into the film, offering stability, good adhesion, and a wider range of appearances from subtle white to various metallic effects. Let's break down these two types further. The floating type is all about that visual punch, high gloss, excellent corrosion protection, perfect for applications where appearance and protection are paramount, like roof coatings needing to reflect heat or anti-corrosion coatings demanding maximum barrier properties. However, because those shiny flakes float to the surface, they don't bond well with the resin underneath, leading to potential flaking or peeling if not handled carefully. Plus, their stability during storage can be a bit temperamental. Then you have the non-floating type. These flakes distribute throughout the film, giving you a more stable, durable coating. They offer good adhesion, making them ideal for industrial applications, automotive parts, and decorative finishes where recoating might be necessary. You get a broader spectrum of effects too, from subtle whites to various metallic sheens. It's a trade-off: brilliance versus stability and versatility. Beyond just floating or sinking, we categorize these pastes by the effect they produce. Fine silver gives you a smooth, bright white finish with decent hiding power, less about the metallic flash and more about solid coverage. Electroplated silver aims for that specific, refined look, mimicking actual plating. Then there's flash silver, available in fine, medium, and coarse grades. This is where things get interesting. The metallic effect changes dramatically depending on the viewing angle, creating a dynamic, eye-catching finish. While visually striking, it typically offers slightly less hiding power compared to the finer types. Where do we see these in action? Everywhere. Industrial paints, from plastic and wheel hubs to metal and glass, automotive coatings, essential anti-corrosion layers, even printing inks. Anti-corrosion is huge, but often the cost constraints mean using the paste primarily for its protective qualities, not necessarily its flashiest look. A significant growth area is waterborne automotive repair paint, driven heavily by environmental regulations pushing away from solvent-based options. Why should we care about switching to waterborne? The advantages are compelling. First and foremost, it's green. We're talking significantly lower VOC emissions compared to traditional solvent-based systems, which is crucial for both regulatory compliance and worker safety. Remember, it's classified as non-hazardous. Performance-wise, especially the floating type, offers excellent corrosion resistance, a critical factor in many applications. Its versatility is another major plus, fitting into a wide array of industrial and decorative coating needs. And let's not forget cost-effectiveness. While initial material costs might vary, the overall production process can become more efficient and compliant, potentially lowering long-term expenses. Plus, innovation is constantly pushing boundaries, like advanced silica nanosedimentation membrane technologies that fine-tune film properties, offering manufacturers greater control and customization while maintaining that eco-friendly profile. Now, handling this paste requires some finesse. before you even think about mixing it into your base coat, pre-dispersion or opening is crucial. You need to dilute it properly. Ideally, use deionized water. If using tap water, let it sit open for 24 hours to allow chlorine to evaporate or treat it appropriately. A general ratio of 1 part water to 1 part paste is a good starting point. Let it soak for about 5 minutes, then gently stir at low speed until it's fully dispersed. When adding this prepared paste to your Waterborne base, do it slowly while continuously stirring the base. You might need to add some Waterborne dispersants or other functional additives to optimize the final effect. Here's a critical point. Avoid high-speed stirring. High shear forces can damage the delicate aluminum flakes and their protective coatings, leading to instability and poor performance. Stick to a moderate speed around 300 to 800 RPM to keep things smooth and bubble-free. Like any good product, proper storage is key to maximizing the lifespan and performance of Waterborne aluminum paste. Unopened, it generally lasts about a year. To ensure that shelf life, store it wisely. Keep it away from direct sunlight, maintain temperatures below 30 degrees Celsius, and ensure it's in a well-ventilated space. Before committing to large-scale use, stability testing is highly recommended. A common practice is to place a sample in a 50 degrees Celsius oven for 7 days. If there are no obvious signs of trouble like excessive bubbling, gelling or skinning, and the coated sample doesn't show significant gloss loss compared to a standard, you can expect roughly 6 months of stable storage at room temperature. If it passes the 14-day test, that translates to a potential 12-month shelf life. Be aware of the bubbling issue, especially in strongly acidic or alkaline systems, as this can build pressure and potentially rupture sealed containers. Understanding your system's pH compatibility is vital. Even with the best practices, you might encounter some common hurdles. One frequent issue is silver flake alignment. If the flakes aren't orienting correctly, the desired metallic effect won't be achieved. The usual fix involves using specialized silver flake alignment agents, which are essentially wetting or dispersing agents designed to help the flakes settle in the right direction. Sometimes, adjusting the overall coating formula itself, perhaps tweaking the binder or other additives, can also resolve alignment problems. Another subtler challenge is self-reaction. Due to slow chemical processes within the paste, you might notice slight differences between a freshly produced batch and one that's been sitting for a while, even within the same production run. There isn't always a specific corrective action listed for this, but being aware of this potential variability is important for quality control and consistent results across batches. So, wrapping up, the shift towards waterborne aluminum paste is clearly underway. It's not just a trend, it's a fundamental change driven by stricter environmental regulations and a growing global awareness of sustainability. This transition presents a significant opportunity for the coatings industry, opening up a growing market for eco-friendly solutions that don't compromise on performance. Expect continued innovation in formulations, application techniques, and new applications as this technology matures.